see if I can put this on a video. Well, this corresponds to this corresponds to this, and this corresponds to this. And they're all similar. So, right, so I can go ahead and do that for now. So let's start with this one. I'm going to use this as my base, right, the one that because I have all three sides. Let's call this x, and let's do that one by one. So, set of portion 2, this side 2 corresponds to this side, which is 1. And then square root of 3, right, this side over here corresponds with x. I can cross multiply, I get 2x equals square root of 3. Divide by 2, divide by 2. And we want to leave it like that, because square root of 3 is a non-repeating, non-terminating decimal that goes on forever. And I don't feel like dividing that by 2, because we're not gonna get decimal that ends, right? We're gonna get again something, a decimal that you're gonna have to round up or down. And besides, it's prettier like that. Okay, you don't have to worry about rounding, how many decimal places. If you want to later on, you can. If the book specifies or somebody specifies, then you can do it. But if not, leave it like that. Done. Let's call this y, and let's solve for that. So again, the portion 2 corresponds to 1, as that 1 corresponds to y. Cross multiply, oops. We get 2y equals 1, divide both sides by 2, and y equals a half. So that one is even easier. You can write 0.5 if you want. I'm writing a half. Then, tiny triangle done. Let's go to the big triangle. Let's call this x, just to be different. And we're going to use corresponding sides. So let's use the 2. In this case, corresponds to 2 times square root of 3. As square root of 3, right? This guy right here corresponds to this, the missing length that we're looking for, x. Cross multiply, we get 2x. On that side, we get something interesting, which some of you might not have seen. So let me write it here, tiny space. So 2x, and then we get square root of 3 times 2 square root of 3. So we get 2 times square root of 3 times square root of 3. That's what we have, right? Because now 2x equals, we can combine these two. So something maybe that, like I said, that some of you didn't know. We can combine those two under the same radical and write 3 times 3. You can combine that. And step by step, if I combine those two numbers, I get 9. So that becomes 2 times square root of 9. We can simplify that even further. What's the square root of 9? Square root of 9 is 3, so all that becomes simply 3. Now I can just 2x equals 6, divide by 2, divide by 2, x equals 3. So this equals 3. Hang on, guys. So, this is lady who presses all the doorbells, even though she doesn't. Long story. Anyways, bottom one. Let's call this y. Again, so we can now use this side or this side. It's up to you, but I'm just going to keep using that. The 2 corresponds with 2 square root of 3, as that 1 corresponds to y. Cross multiply, we get 2y, and then 1 times 2 square root of 3 is just 2 square root of 3. Divide both sides by 2, and y equals square root of 3. And we're done with that, the big triangle. Tiny triangle. Let's call this x, and again, let's set up our proportions. So 2 corresponds to this time x, and that 1, and sorry, we can't use that 1 because we don't have the value here. So that square root of 3 corresponds to 1. Cross multiply, we get 2. On the other side, we get square root of 3x. We're going to divide both sides by square root of 3. And x equals 2 over square root of 3. Let me write that down. Sorry, 2 over. There you go. And then let's do the last one. This is y. So let's set up proportion again. 2, that 2. Well, 2 matches up with, I don't want to use that fraction. So for this one, I'm going to use this guy over here. Square root of 3 matches with 1, corresponds to 1. As this one, right, on this triangle, corresponds to y. Oh, so much easier. Cross multiply, we get y, we get square root of 3y. And then 1 times 1 is just 1. Divide both sides with square root of 3. That crosses out. And y equals 1 over the square root of 3. So, there you go. Get all the sides. It's a nice little problem, isn't it? Alright, that's done. Now I'm going to attempt this one. 22, that goes here. Let me make some lines. Or sleepy faces. That's gone. 73, watch only Tiny. Oops, this is Tiny Toons. This is Animaniacs, and this is Pinky and the Brain. 73, watch only Tiny Toons. So I'm going to put it over here. Cross that out. I want to see it again. 136, watch Tiny Toons. 136, watch Tiny Toons. Can't do anything because I'm missing this, this, and this. 14, watch only Animaniacs and Pinky and the Brain. So I can watch that, and that only comes in handy. 31 students watch only Tiny Toons and Pinky and the Brain, and that will be here. 63 students watch Animaniacs, which is these 4, this, and this. I can't do anything. 135 students do not watch Pinky and the Brain for some incomprehensible. So, who are the kids that don't watch Pinky and the Brain? Well, people that don't watch Pinky and the Brain. So, let me take that back. So if 135 don't watch, here's a total. And I'm going to say that 135 don't watch Pinky and the Brain. That means if I subtract 65 do watch Pinky and the Brain. Right? So that's what I get from this statement. 135 do not watch Pinky and the Brain. That means that 65 do watch Pinky and the Brain. So who are the people who watch Pinky and the Brain? So it'd be this group here, that group here, that group here, and that group here. Now, it seems like this is it. So I'm gonna put letters A, B, C, D, because there's nothing else I can do. And this is gonna help me set up set up an equation. So the people who watch Pinky and the Brain are the 31. 14 plus C plus D, that should equal 65. 31, 14 is 45, I think, plus C plus D equals 65. If I subtract 45 from both sides, I get that C plus D equals 20. All right, I'm going to keep that there. I need some room here. Now, 63 students watch Animaniacs, and then Animaniacs is the A, B, C plus 14. So I'm going to write A plus B plus C plus 14 equals 63. I can write that A plus C plus B plus C plus, if I subtract 14 by each side, I get 63 minus 14. 49. So A plus B plus C equals 49, but guess what? Nothing. Sorry, I was gonna thought of using C plus D, but I can't. So I have another equation. 136 watch Tiny Toons. So 136 watch Tiny Toons. I can use Tiny Toons will be the 73 plus 31 plus A plus C equals 136. I can combine these two. That becomes 104, right? So 104 plus A plus C equals 136. If I subtract 104 plus 8 from each side, I'm going to get 32. Now, can this information help me? Yes, I can go back here and use this to find B, right? So I know what A plus C is, and if I substitute, so over here, I'm going to replace the A and C, so I'm going to get, let me change colors. I'm going to get B plus 32, which is the same thing as A plus C, equals 49. I'm going to subtract 32 from each side, and I get B equals 17. So allow me to just change this to 17. Okay. Are there other, is there A plus C? I can't do anything. Does that help me with, so B. Okay, so now there's one more equation that I forgot to write. I can write the sum of all these parts. So let me write A plus C plus D, and I'm going to write all the numbers, plus 73, plus 17, plus 31, so A plus C plus 73, plus 17, plus 31, plus 14. Let me write this again. So A plus C plus D plus 73 plus 31 plus 17 plus 14 plus 22. Don't forget the number outside. All that has to equal 200. So I'm going to simplify that. A plus C plus D plus, and let me add 73 plus 31 plus 17 plus 14 plus 22 equals, looks like 73, 31, 17, 14, 22, 1, 3, 4, 5, 157 equals 200. Subtract 157 from both sides, and A plus C plus D equals 43. Now, I can stop here. I mean, well, I'll continue. C plus D is 20. Now I can use the other piece of information that I have. So this comes in very handy, C and D. I can change this, and I write A plus 20 equals 43. Subtract 20 from each side, and I get that A is 23. So wherever A is, I'm going to take that away, and I write 23. Can I find out what C is now? I know what A is. So if I go back here to this equation, I can replace the A with 23. So I'm going to get 23 plus C equals 32. If I subtract 23 from each side, I get C equals 9. Go down, C equals 9. And I need one where, so C here equals 9, so I can come back to this one over here, change that C and make it into a 9. So now I have 9 plus D equals 20, subtract 9 from each side, and D equals 11. And then the last one over here, D equals 11. Okay? Yeah, it's a lot of work, but it's nice. So these are really nice problems. Okay, 30 people. So I'm going to put that over here. Let's call this US. This is Wimbledon, which is in England, and the Australia Open. 30 people have not attended any. Okay, 10 people. Let me put the lines. Sleepy people. I've been to all three. Check, check. 25 people have been to Wimbledon and the Australia. So these are this and, right? So 25 people have been to the Wimbledon and the Australian, so that includes the 10 over here. So I have to do 25 minus a 10, so that gives me 15. So now I have two groups, and all those groups have attended Wimbledon and the Australian. Doesn't say only. Okay, so that's why we include the 10 over there. 20 people have been to the US Open and the Australian. The US Open and the Australian, but not to Wimbledon. So they can't be where the Wimbledon circle intersects. So, but they have been to both. So 20 people have been to the US. We can put that right there. That's okay. So far, so good. 65 have been to exactly two of the tournaments. So that two of the tournaments is this guy here this guy here, and this guy, not including the 10. So 65 minus 20 minus 15. So the people who have been to exactly 2 tournaments is the 20, the 15, and that missing group. And if the total is that, I can subtract 65 minus 20, which is 45, and 45 minus 15 is 30. So that becomes 30. Good. 165 people have been to the US Open or Wimbledon. So that would be this group, and this one, the OR group. Okay, which I can't do anything with. 120 people have been to Wimbledon or to the Australian. Wimbledon or the Australian. Again, this group, and this group. So I guess I'm setting up equations again. So let's call this A, B, C. 120. The 120 who have attended Wimbledon or Australian would be the C plus 15 plus B, and those 3 groups make up the 120. So let's put this alphabetically. So B plus C plus 15 equals 120. Subtract 15 from both sides, and we get B plus C equals 105. All right. I set up another equation. 165 have been to the US Open or Wimbledon. So that would be this one, and this one. Hang on a second. 120 people have been to Wimbledon or the Australian Open, but doesn't say only. So Wimbledon, hang on a second, let me just go. Wimbledon, Australian. So this group will definitely be to one of them. It's or. Okay, so not and this one. And oh shoot. Sorry about that. 165 people have been to the US Open or to Wimbledon. It would be this. This group and this group, just making sure. US Open and Wimbledon. I'll be right back. Alexa, stop.
1 hour timer stopped on Alexander's second echo.
Hang on a second. 120 people have been to Wimbledon US Open. That would be this. This guy have been to either or. Sorry. Yeah. No, sorry. 120 either or. Wimbledon and Australian Open. Yeah, either or. Either or. Let's see if I can just so now I'm having doubts about that statement here. So 165 people have been to the US Open or to Wimbledon. It doesn't say only, right? So this group have been this group here has been to the US Open or to Wimbledon. This group likewise has been to either or. This group has also been to either or. These guys have also attended Wimbledon or the US Open, like these guys and these guys. So it's actually the sum of all these 2 circles except the C. So it's A plus B plus 30 plus 20, plus 10, plus 15, and we're doing US Open or Wimbledon. That all equals to 165. So A plus B, 50, 60, 75 equals 165 minus 75. So A plus B equals, let's see, 165 minus 75 equals 90. So now let's do the 120 group here. 120 is would have been these people have gone to either Wimbledon or to the Australian Open, but it doesn't say only again. So Wimbledon, Australian Open, everybody who's had attended one or the other. So we're going to write B plus C, right? Let's take care of the variables, plus everybody, plus 30 plus 20 plus 20, 30 plus 10 plus 20 plus 15. So plus 30 plus 20 plus 10 plus 15, and this is going to give me, what is this going to give me? B plus C, that's Wimbledon and the Australian Open, that's equal to 120. So B plus C again, that equals to 75, equals 120. And B plus C, if you subtract 175 from each side, equals 45. How does that help me? It doesn't, because I need one more equation. The last equation, okay, let me drag this up if I can. No, not that. I can't. So the last equation that I'm going to use is the one that I always forget, is the one that I can add everything. Alright, so all the parts together, so I'm going to go A plus B plus C plus 30 plus 20 plus 10 plus 15, and I'm not going to forget this 30 that are outside. So 30 plus 20 plus 10 plus 15 plus the 30 who's outside, and that in this time gives me 200. So A plus B plus C, let me add that, 30, 50, 60, 75, 105, plus 105 equals 200. Subtract 105 from each side, and A plus B plus C equals 95. Now, I can use that equation, right? I know what A plus B is. I know what B plus C is, so it doesn't matter which one. So let's use this. A plus B equals 90. So this, change it to red. So if I change that and make it 90, because I know A plus B is 90. So 90 plus C equals 95. So if you subtract 90 from each side, we get the C equals 5. Okay, so I can use that information now. Go over here and change that C to 5. So I get B plus 5 equals 45. Subtract 5 from each side, and B equals 40. Right? And now I can take that B equals 40, put it over here, change that to 40. And I get A plus 40 equals 90. Subtract 40 from both sides, and I get A equals 50. So, by God, I hope I'm correct. I'm going to change, I'm going to put values. This is 50. B is 40. And C equals 5. So if I add all my numbers up, I should get 200. So give me a second to add it in the calculator. So I'm going to add 50 plus 30 plus 20 plus 10 plus 40 plus 15 plus 5 plus 30. That should give me 200. So 5 and 5 is 10, carry 1. 5, 10, 11, 12, 13, and 7 is 200. Oh, look at that. I actually did it right. Okay. So the tricky part was these two, and not having the only. Okay, so that was the tricky part, was this question. All right. Okay. That video was longer than it should have been.